Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be working on an optimization problem. So let's jump right in. So today we're asked to find the largest rectangle by area that can be inscribed inside a 3, 4, 5 right triangle, so that one of the corners of your rectangle is the right angle of your triangle. So let's first off draw the triangle, and I'm actually going to I know what's going to happen, so I'm going to put it in first. When you run into a problem like this, generally speaking, you want to put it on a coordinate plane. So if you have one shape inscribed in another shape, putting it on a coordinate plane is going to be very helpful. So let's put it on this coordinate plane, and then we're going to put the 4 side on the y-axis and the 3 side on the x-axis. And we'll give those points. So that's 3, 0. And then this point here is 0, 4. And those are going to come in handy in just a minute. So let's draw in the hypotenuse of this triangle. And there we go. So now we need to inscribe a rectangle so that one of the corners is at the right angle. So that means the rectangle is going to start at 0, 0. And it's going to look something like this. Don't know precisely what it's going to be, but it's going to look something like that. So we need to come up with the size of this rectangle in a way that we can find the maximum size. And generally when we want to find the maximum of something, that means we're going to be using a derivative. So let's call the horizontal length, let's call that x, and then the vertical length, let's call that y. Just because that makes sense. And then the area of that rectangle is just going to be x times y. Now, when I take a derivative, I usually want to take the derivative with respect to one variable. And right now I've got x and y. But if I look at what's going on here, I see that y is constricted. Y is restrained by this hypotenuse. So could I come up with an equation for that hypotenuse so that I know where y is along the hypotenuse? And it turns out that, yeah, I can if I figure out the equation of this line. So to find the equation of the line, I need a slope, which is going to be 4 down and 3 right. So that's negative 4/3. And then I need a y-intercept, which is just 4. So then the equation of my line is y equals negative 4/3 x plus 4. Now that y value there describes where this point right here is going to be, depending on whatever x I plug into it. So the width of my rectangle, whatever I give it, is going to, if I plug it into my line, is going to give me my height. So that means that if I take this equation and I plug it into my area formula, I get to know what the area is of that rectangle just by knowing the x value, the length of the rectangle. So I'm going to multiply those two together. So it's not x times y anymore. It's x times negative 4/3 x plus 4. And let's go ahead and distribute that x in. Look at negative 4/3 x squared plus 4x. So now if I want to find the maximum area, well, I need to find the derivative. I need to find the critical point for this area. So I'm going to take the derivative and set it equal to 0. And then I'm going to test the extent of my x value, how far to the left and how far to the right it can go to find the absolute max. So a prime is just using the power rule. So that's negative 8/3 x plus 4. So let's set that equal to 0 and let's solve it. So I get negative 8/3 x equals negative 4, and then multiply both sides by negative 3/8. And the 8 and the 4 reduce, and so we get x is equal to 3/2. So that's the x value that's going to give me my critical point. So now I need to go and test my 2 different values for x, or my 3 different values for x. I need to test when x is equal to 0. So I'll test when x is equal to 0. I'll test when x is equal to 3/2. And then I'll test when x is equal to 3. When we want to find the absolute max of something, we generally have to test where the critical points are and then the extent of what makes sense for x. So when x is equal to 0, then the area is going to be 0. If x is equal to 3, you plug that in, and you should get 0 as well. So plug 0 into any of the versions, but specifically this second area version here, you get negative 4/3 times 3, which is negative 4, plus 4 is 0. So both of them give us 0. And then if we plug 3/2 in, that's a little bit more work, but we get negative 4/3 times 3/2 squared plus 4 times 3/2. And that is going to be equal to, well, we get 9/4 there. So we get negative 4/3 times 9/4 plus 4 times 3/2, which is 6. And then here we get the 4's cancel. The 3 and the 9 reduce to 3. So we get negative 3 plus 6, which is 3. So the area of the rectangle that can be inscribed in a 3, 4, 5 right triangle, the biggest one is area 3. So that's it. That's the end of the problem. If you have any questions, please feel free to put them in the comments below. And if you have any other problems that you'd like to see done, please put them down there as well. Thanks for watching, and I'll see you on the next problem.